MS Ramaiah University of Applied Sciences.
Hi students, let us discuss an op-amp experiment to design, build and test active filters like low-pass filter, high-pass filter and band-pass filter. To design and test the performance of a low-pass filter using IC MU-A741. To design and test the performance of a high-pass filter using IC MU-A741. To design and test the performance of a band-pass filter using IC MU-A741. The design of the active filters is shown here. The filters are designed for the cutoff frequency of 1 kHz. The equations for designing low-pass, high-pass and band-pass filters are shown here. The figure shows the circuit diagram of low-pass active filter and the output waveform. It allows the frequencies up to the critical frequency of the circuit. The critical frequency is the frequency at which the circuit changes the response. Apply an input voltage Vin of 1 volt peak to peak and take the readings for different frequencies starting from 100 Hz to 2 kHz and calculate the gain of the circuit. Plot the logarithmic graph. Measure the critical frequency of the circuit after plotting the graph. The figure shows the circuit diagram of high-pass active filter and the output waveform. It does not allow the frequencies up to the critical frequency of the circuit. After the critical frequency, the output gradually increases. The critical frequency is the frequency at which the circuit changes its response. Apply input voltage Vin of 1 volt peak to peak. Take the readings for different frequencies starting from 100 Hz to 2 kHz and calculate the gain of the circuit. Plot the logarithmic graph. Measure the critical frequency of the circuit after plotting the graph. The figure shows the circuit diagram of band-pass filter and the output waveform. It passes the frequencies up to the cutoff frequency, and at critical frequency of the circuit it gives a maximum peak or sharp edge. After the critical frequency, the output gradually decreases. The critical frequency is the frequency at which the circuit changes the response. Apply input voltage Vin of 1 volt peak to peak. Take the readings for different frequencies starting from 100 Hz to 2 kHz and calculate the gain of the circuit. Plot the logarithmic graph. Find the lower cutoff frequency, higher cutoff frequency and critical frequency of the circuit after plotting the graph.
Dear students, today I am going to teach the experiment of the active filter design. So in that active filter design we have 3 filters. One is low pass filter, high pass filter and band pass filter. So first I am going to teach the low pass filter. The aim of the experiment is to design a low pass filter for 1 kHz frequency, cutoff frequency. So the required components for this experiment is signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, harp wave and noises that will be used to generate the signal to the input for the circuit. Regulated DC power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have 2 main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have 2 main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color, and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as the channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is a series connection. So this is a series connection in x-axis, and this is a series connection in y-axis till this division that will be counted to 5. Till that it is a series connection. After that this is one connection. Resistors. For this experiment I am using different resistor segment. One is 5.6 kilo ohm resistor, 6.2 kilo ohm resistors, and 10 kilo ohm resistor. Capacitors. I am using the capacitor of 0.1 microfarad. IC MUA741. In this experiment I am using MUA741 IC. This is the notch that will indicate the terminal numbers of the IC. From the left hand side, 1, 2, 3, 4. This is 5, 6, 7, 8. It's a total package of 8 pin IC. Connecting wires and patch cards. So now I am going to connect the circuit of active low pass filter design based upon the circuit diagram. Now I am going to connect the circuit like this. So I am taking the circuit board. So I place the IC to the circuit board. So now I am going to connect the pin number 2 to 5.6 kilohertz. This is 5.6 kilo ohm resistor I am taking. So 5.6 kilo ohm resistor that will be connected to pin number 2 to pin number 6. See, this is pin number 1 and this is pin number 2. Pin number 2 to pin number 6. This is 5 and this is 6 I am connecting here. So this will be connected to pin number 2 and pin number 6. Next I am going to take 10 kilo ohm resistor. So this is 10 kilo ohm resistor. I am going to connect this 10 kilo ohm resistor to pin number 2 to ground. So this is pin number 2 and this is connected to ground. I am connecting here. Now I am going to connect the 1.6 kilo ohm resistor to terminal number 3. So this is terminal number 3 to somewhere in the circuit board. I connect like this, and another 1.6 kilo ohm resistor I need to connect with a series of this resistor 1.6 kilo ohm. So I connect like this. I connect this point to somewhere in the circuit board. I connected like this. Now I am going to connect the capacitors. One capacitor is from the terminal 3 to ground. So this is terminal number 3. Terminal number 3 to ground I need to connect. So this is terminal 3 and this is ground. Another capacitor I need to connect it to the pin number 6 to the pin number 3. We have connected 1.6 kilo ohm resistor. So middle point of this junction I need to connect to pin number 6 with a capacitor. So like this is the point. So I need to connect this point to pin number 6. This is pin number 6. Now both the terminals will be connected. Now I am going to connect the input signal to the circuit using the patch card. So I am taking the patch card and I am going to fix the patch card like this. So I provide the input for this first. I am taking the wire, the positive end I will give here, and the negative end I made to ground. This is the ground connection. Next I am going to connect the DC regulated power supply. The positive end of the DC regulated power supply will be given to pin number 7. So this is I am giving like this. This is pin number 5, 6 and this is 7th pin. I am connecting here. The negative end that will made to ground. Made this to ground, and another positive end of the DC regulated power supply is connected to ground. And the negative of the supply will be given to the pin number 4. So this is pin number 4. Connecting here. Next I am going to connect the output. I am taking other patch cards. First I am going to connect the input terminal by using a patch card. This is I am using for the input. So positive end of this will be connected like this. I will give the positive terminal this to input point. So this is the input point, and the negative I will make to ground. So this is the ground connection. I am taking another patch card to see the output. The positive end I will given to the pin number 6. This is pin number 6, and the negative end given to the output ground. This is ground. This completes the circuit connection of active filter design. This circuit is designed for low pass filter design for 1 kilohertz frequency. So I am going to switch on this signal generator to give an input for the circuit, and I am going to switch on the digital oscilloscope to see the output of this circuit. I am going to switch on this DC dual power supply to provide a voltage to the circuit. So we need to set this to 12 volt, whether it may be any voltage, but we must set this both terminals to 12 volt. It's already set it to 12 volt. Now I am going to vary the frequency from 100 hertz to some 1 kilohertz. So here this is the knob I can use, otherwise we can set this like this, 200 hertz peak to peak I given. Still I am getting 3 volt peak to peak at the output. 300 hertz, same the frequency will be varied, but the amplitude will be the same, 3 volt peak to peak. Some 400 hertz also. Three volt peak to peak. I changed to some 600 hertz. Now you see the amplitude will be slightly decreases to 1 division, 2 division, 2.3 volt peak to peak it have, because some I'll put some 500 hertz. So exactly it shows some 2.8, 400 hertz. It will shows 2.8, some 300 hertz, 3 volt peak to peak. Likewise, you can check the various frequencies. Directly I'll go to some 500 hertz. It will show some 2.8 volt peak to peak, 600 hertz, 2.8, some 800 hertz I will put. See, drastically it will be changed. It will give some 2 volt peak to peak, some 0.3 will be reduced. Again I'll put 1 kilohertz. See, complete change. Some 1.2 volt peak to peak it will be available now. If we change to some other values, some 1.3 like that, it drastically decreases the output like this. If the frequency will be varied, the amplitude of the signal will be get reduced. So we can conclude that the low pass filter that will passes the signal up to some critical frequencies. After that the output signal will get reduced. So here the critical frequency is 600 hertz, because after 600 hertz the output will get reduced. So this completes the experiment of low pass filter design. Dear students, now I am going to explain the active filter design for high pass filter. So we already know what is low pass filter and how we are going to design. So both are slightly similar. So instead of placing a resistor, we need to place the capacitor values. Instead of placing the capacitor, we need to place the resistor values. The small similar small changes that will be happen between high pass filter and low pass filter circuit connection. So now I am going to connect the circuit based upon the circuit diagram for the high pass filter, but components what we are using for the low pass filter, the same components we are using for the high pass filter design. Now I am going to start the circuit connection. I am taking the circuit board and I place the IC MUA741 to the circuit board. So I am taking the 5.6 kilo ohm resistor and I place this as the feedback between the pin number 2 and the pin number 6. So this is pin number 1 and 2, this is pin number 2, pin number 6, this is 5 and 6, this is the pin number 6. I made this as a feedback. Now I am going to connect the resistor 10 kilo ohm to pin number 2 to ground. So resistor number 10 kilo ohm that will be connected to pin number 2 and pin number 2 to the ground I connected. So this is the ground connection. And 1.6 kilo ohm resistor I am taking. So I will connect the 1.6 kilo ohm resistor to pin number 3 to ground. So this is pin number 3 and I made this pin number 3 to ground with 1.6 kilo ohm resistor. I am taking two capacitors. One capacitor that will be connected to pin number 3 to somewhere in the circuit board. So this is pin number 3 and I connected somewhere in the circuit board. After that I am taking another capacitor. I will connect this one to the junction of this capacitor to somewhere in the circuit board, make it as a series to the circuit. After that I am taking 1.6 kilo ohm resistor and I made the 1.6 kilo ohm resistor that will be connected to the junction of these two capacitor and the pin number 6 like this. I am taking the patch card to connect the input for the circuit. So I connected the patch card and I am taking the wire to connect the positive terminal of the circuit to the junction of the capacitor here, and the negative I made to ground. This is the ground connection I made. Now I am going to connect the DC regulated power supply. So positive end will be given to pin number 7. This is pin number 5, 6 and this is 7, and the negative end I want to make to ground. The negative end I will put it to ground. Here another terminal I am taking the positive, I need to put it into ground. This positive I will made to ground. The negative end that will be given to the pin number 4. This negative end I will given to the pin number 4. This is pin number 4. This pin number 4. Now I am going to connect the output terminals to see the input. I am connecting the patch card to here, the terminal 1. So I am taking one wire to positive connection. I will place this to input junction, and the negative terminal I place to ground. And another patch card I am taking to connect the output terminal at the terminal 2. So positive end I will be connected to the pin number 6. So this is pin number 6, and the negative terminal I am going to connect to ground like this. So this completes the circuit connection of a high pass filter design for the frequency of 1 kilohertz. So now I am going to switch on the signal generator, digital oscilloscope and DC regulated dual power supply. I want to set this DC regulated power supply to 12 volt in both the terminals. This side also I need to set to 12 volt. I want to set the frequency. We are designing this for 1 kilohertz frequency cutoff range. So approximately we can get around some 1.4 kilohertz as a critical frequency in this circuit. So now I'm going to set this frequency first. So frequency to some 100 hertz I will give first. Frequency some 100 hertz. 100 hertz I will give. Switch on the input signal. Now you can see by using auto set, this is the input signal we are getting, so but we are not getting any output signal. So you can raise this to this frequency to some 200, a slight variations that will gives an output, increase to some 400, 500, so we can get a small signal there. So later on I'm going to turn off the input signal, so I'm using only the output signal as a reference. This is the output signal. So further I increase this to some 1 kilohertz directly, so till that it will give an incremented version of the output in the amplitude, you see. So for example, if you say some 700 hertz, the output will be 2 volt peak to peak. So if we increment to 800 hertz, it will give some 2.2 volt peak to peak. 900 hertz, 2.3 volt peak to peak. 1 kilohertz, so for the 1 kilohertz it will give some 3.2 volt peak to peak. So later on I will increment to 1.1, so it gives 2.4 volt peak to peak. 1.2, it will give 1, 2, 3, 4 volt peak to peak. So I'm going to adjust the scale like this, 4 volt peak to peak. I further incremented to 1.3, 4.1 volt peak to peak. 1.4, it will give 4.2 volt peak to peak. Further I incremented to 1.5, 4.3 volt is the peak to peak. 1.6 also 4.2 volt is the peak to peak. 1, 2, 3, 4, 4.1, 2, 3, 4. 4.4 is the peak to peak. Again you incremented to some 1.6, 1.7, 4.4 is the peak to peak. 1.7, 1.8, 1.9 also you can get the same. Further you incremented like this, it will give a constant value. So later on it will start to give a constant value. So at the output terminal, these are constants we are expected. Now it start to increases to some other voltages. Now it will be raised to 1, 2, 3, 4, 5, 6 volt peak to peak after 5.8. So we don't go to that much of design. We are using only for 1 kilohertz frequency circuit design. So in that, the critical frequency of this high pass filter is 1.5 kilohertz. This completes the experiment of high pass filter design for frequency of 1 kilohertz. Now I am going to connect the circuit based upon the circuit diagram of band pass active filter design. So the required components for this experiment is signal generator, regulated DC power supply, digital oscilloscope, circuit board. The IC what I am using, that will be the same MU741 IC. So I am using the capacitor value 0.01 microfarad and resistors 6.2 kilo ohm, 10 kilo ohm resistor, 100 kilo ohm resistor. Connecting wires and patch cards. So now I am going to connect the circuit. I am taking the circuit board MU741 IC. I am taking. I place this IC to the circuit board. Now I am going to connect the capacitor 0.01 microfarad to pin number 2 to somewhere in the circuit board. So this is pin number 1 and 2. I am connecting this capacitor here and I connected somewhere in the circuit board like this. Now I am taking another capacitor to connect the junction of the capacitor to terminal number 6. The junction of the capacitor is this one here to pin number 6. I need to connect. This is 5 and 6. This is pin number 6. I'm connecting this capacitor like this. Next I'm taking 6.2 kilo ohm resistor and I place the 6.2 kilo ohm resistor junction to the ground. So this is the junction and I made this to ground here. Next I am taking another 6.2 kilo ohm resistor and I place that into pin number 2 to somewhere in the circuit board. So this is pin number 2 and I placed it into another somewhere in the circuit board point here. So next I am taking the 10 kilo ohm resistor and I place the 10 kilo ohm resistor load to ground. So there is pin number 6 to ground. So this is pin number 6 and this is the ground connection. Next I am taking 100 kilo ohm. 100 kilo ohm I need to place to pin number 6 to pin number 2. So this is 5 6. This is pin number 6 and this is to pin number 2. Now I am taking the patch card. I connect the input to the circuit. I place this patch card to here and the positive terminal positive of the signal will be connected to the junction point here. This is the input point and the negative will be placed to ground connection. This is the ground and I am taking another patch card to connect the input signal. So this is the input signal I am connecting. I am taking wire positive and I place to the same point and the negative I place to ground. Next I am taking the DC regulated dual power supply. So I place the positive to pin number pin number 7 5 6 7. This is pin number 7 I placed here and the negative give to ground. This is the ground connection. Next the negative of this will be given to pin number 4. This is pin number 4 and even the positive wire of this positive terminal to the ground. I am taking one more patch card to see the output of this circuit. I connected the terminal number 2 and the positive end I will give to pin number 6. So this is pin number 6 I am connecting here and another terminal I made to ground. This is the ground connection. This completes the circuit connection of active band pass filter design. We have designed the circuit for 1 kilohertz of cutoff frequency. So we can expect the critical frequency of this circuit is around some 800 hertz. So now I am going to check. So to check we need to switch on the input signal generator as an input for the circuit. Now I am going to switch on the digital oscilloscope as output for the circuit and switch on this DC regulated dual power supply. You set the value of DC regulated power supply, so 12 volt in both the terminals. Now I'm going to adjust the frequency. Before that I need to turn on the signal. So input and output you need to see. So here I need to adjust the frequency column. So this is the frequency button. So frequency I need to adjust. Some 100 Hertz I will adjust first. 100 Hertz. So you can get the signal like this. This is the frequency adjusting knob. You can adjust the frequency from 100 Hz to 200 Hz, 300 Hz, 1 kHz, megahertz, everything. So you can use this as a tuning frequency terminal. So now I am going to adjust the frequency to 100 Hz. So now you can see the output. We are not getting an exactly this waveform. So if you increment it to 200 Hz, you are getting some signal. 300 Hz. So it is around the whole how much peak to peak. Change the position. 0.1, 2, 3, 4, 5. 0.5 volt peak to peak we are getting at the output terminal. So increment it further. So adjust the position. See 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. 0.6 is the output for 400 Hertz. For 500 Hertz it comes around 1.2, 1.4, 1.6. 1.6 is the output for 500 Hertz. Next you increment it to 600 Hertz. You can get the signal of 1 to 2.2 volt peak to peak. Later on you increment it to 700 Hz. 700 Hz you are getting the output 1, 2, 3, 3.2 volt peak to peak. Later on you increment it to 800 Hz. Your output will be 1, 2, 3, 4.2 volt peak to peak. Later on you increment it to 900 Hz. 900 Hz also your voltage will be 1, 2, 3, 4.2 volt peak to peak. So increment it to 1 kilohertz. So you are getting for 1.1 kilohertz you are getting around 1 to 2.4. See, from the beginning, from the 100 Hertz we started to take the reading. From the 100 Hertz it will drastically increases the signal. Later on after 800 Hertz it will start to give the decremented output at the output terminal. See, I further keep on increasing the frequency in the input signal. It gives a decremented output waveform at the output terminals. So what we conclude, the band pass is a frequency that will be, we can expect it will pass the frequency of the cutting frequency of 800 Hertz. See, first in the beginning position it will gives a constant pass up to some critical frequency. After the critical frequency start to decreases the output. So from this experiment or from this design we conclude that the band pass filter what we are designed for 1 kilohertz that will gives a critical frequency of 800 Hertz. So hence we complete the experiment of band pass filter.
At MSR UAS, we spark your imagination unlike any other.